Okay, now we're going to do modeling the consumer, lesson 3A. We got Osgood French Fry Company. It sells gourmet French fries. At its regular price of $4.84, it sells 237 bags in an average hour. It collects really good data on its customers. They're high earning professionals who work as doctors, lawyers, and investment bankers. It decides to experiment with selling its French fries at a lower price to see if it can expand its customer base into middle income earners. When it analyzes its data after lowering its price to $2.42, it notices that its high earning professionals bought the same amount of French fries as they did prior to the change, but it increased its sales by 69 in an average hour. Okay, so we have 237 at the high price, right? And then lowering the price to 242, we didn't lose any of them. We still have 237 of them, right? But we gained 69 customers per hour. So this is at the high price. At the lower price, we kept them, but we added those, right? So our quantity demanded is 237 at the high price and 306 at the low price. Make sense?
Yes.
And then we just, type in our answer, and then we can check it by pressing enter with our cursor in the box. Now, I need Excel for this, so I'm going to copy this table to here. And then I'm going to replace this with 237, replace this with 306. The problem with just having two rows of data here and two columns of data, it confuses Excel, right? If you just do an insert scatter plot, it thinks this is X. These are both X values, and it thinks these both are Y values, right? That's what it's doing here. So we can't do that. So what I'm going to do is I'm going to add a third row here, and I'm going to make them red. And I'm going to call this 500. I'm going to call this 1. Okay, so now when I do this, Excel is going to think this is the column of X's, and this is the column of Y's, and that'll be correct. So now when I go to insert, it actually does it right. See that? It actually does it right. I'm going to get rid of the made up point there, right? That 500 and the 1 were made up. I'm going to get rid of that by moving this up here. See that? Then I can go ahead and delete these. So what I'm going to do here is I'm going to right click, add a trend line. I'm going to click display equation on chart. And this is our demand equation. The price is on the vertical axis. The quantities are on the x-axis. That's what we want, right? You see that? 237 and 306. Well, 237 is between 200 and 250. And 306 is just to the right of 300, right? And this height is between 2 and 3. So this price is 242. This dot is between 5 and 4. So this dot is at a height of 484, right? And I can call this demand. Okay, so you got it? You got your equation?
Yes.
Okay, I'm going to have to revisit the instructions here. Yeah. I think when I did this problem initially, Excel didn't have this issue. Now it seems to have an issue with when you only have two pairs of values in the scatter plot. Okay, so now we can fill in the slope. The slope is the value that is multiplied by the right-hand side variable. Now, this is in terms of y and x. this is in terms of P and Q, right? The P is the Y variable and the Q is the X variable, right? So over here, X here is our stand-in for Q. And Y is our stand-in for price, right? When you have a point, the first number is on the X-axis, the second number is on the Y-axis. So this column here are our Y values, and this column is our X values, right? So what we have to do before we do that, though, is we have to right-click on this equation to format trendline label. And we want to change it to increase the accuracy of the model. We want to increase the decimal places so that we have 4 decimal places. Okay. So we did there, we changed the category to number, and then we added 4 decimal places. Got it?
Yes.
Okay, so you should have 4 decimal places here, right?
Mhm.
To do this in sheets is really difficult. Now I'm going to copy the value. I'm going to copy the value in front of the X. Whoops. I might have to use my keyboard. I want to copy that number there. So I'm going to hit Control C. This number is times X, right? I want to put it here. Notice I have a negative right there, right? A negative and negative makes positive. That would mean the relationship is upward sloping. So I need to get rid of the negative symbol there, right? Because that's my minus 0.0351. And then this thing right here that's not multiplied by anything, this is called the intercept, right? That's called the y-intercept, the price intercept. And I'm going to hit enter to make sure I get it right. Did you get it right?
Yes.
Okay, good. All right, sweet. So that's my demand curve, right? Now, what I'm also going to do is I'm going to grab this equation. I'm not going to copy the y part. I'm going to copy just the equal sign and everything to the right of it. And again, I'm going to hit Control C. And I'm going to come down here. I'm going to paste it right here with Control V. If you have a Mac, it might be Command, but I think it's Control. I'm going to get rid of the spacing. Now the X, I'm going to replace the X with asterisks for times. And then I'm going to click on the cell to the left of it, A5. You see that? Now nothing is in A5. So when there's nothing in a cell in Excel, Excel numerically treats it as 0. So what's going to happen here is when I hit enter, it's going to take the value in A5, which is nothing. Numerically, that is 0. It's going to multiply it by this negative number, right? And anything times 0 is 0. And it's going to add that to the intercept. And we're going to get 13.1522, right? I'm going to change this to 2 decimal places. Now, if I change this to 1, this number changes to 13.12. Why? Because I'm basically what I'm doing here, not basically, what I'm doing here is I'm multiplying 1 times this negative number, right? And 1 times this negative number to 2 decimal places is a negative 0.04, right? And I'm going to subtract that from 13.1522. And I get 13.12, right? So this number is not quite as big as the intercept, right? Because we have to go down by this value when X goes from 0 to 1, right? So why did I do that? Well, down here, it says the maximum price the consumer with the highest willingness to pay is what? Well, if I extend this line to the intercept, right? And I can do that by clicking on it. I deleted the line for a second there. If I pull that down, notice what happens here. It includes this value in the scatter plot, right? I'm going to change this blue dot here. I'm going to change it to red. Okay, then I'll reinsert the equation again. Add trend line.
No.
The height of this red dot represents the maximum this very first consumer is willing to pay. And I generally call that the LeBron James price. LeBron James is really wealthy. His time is very valuable. He wants to spend it in the gym or the weight room, getting stronger and just getting better, right? So he's got a huge willingness to pay, right? Because he can afford it, right? He's willing and able to afford it, right? So the person that is first in line for anything is willing to pay a lot more money. Time is money, right? Your time is worth money. I could be waiting in line for a week to get my iPhone at the iPhone store across the street from Central Park in Manhattan, or I can work and make $5,000, right? Time is money. So people who are generally in line first are willing to pay the highest amount of money, right? And firms would really like to know what your willingness to pay is. And they try to do it with internet purchases. If you're generally a person that looks for 1,000, clicks 1,000 times to find a really good deal on an iPhone phone case, or you click 1,000 times to find a really good deal on a hotel or on an airline, chances are firms know that, right? But because of your browsing history, right? I mean, Google gives you away a lot of stuff for free because they want to collect this data on you, right? But if you're a one-click shopper, right, whatever thing you see first, you click and buy, you're probably willing to pay more for things, right? So I wouldn't be surprised if you're a one-click shopper and I'm a 1,000-click shopper. If we did a search for a product on my laptop and your laptop, I wouldn't be surprised if the prices you see are higher than the prices I see, right? And they probably somehow figure out how much income you make, right? If you're using a really expensive laptop and I'm using a very expensive old laptop, they'll probably assume our incomes are different too, right? So they're trying to get at what you're willing to pay for stuff. Somebody with a lot of income who does one-click shopping is probably willing to pay a lot more money than a guy with an old laptop who posts pictures of him and his kids in a 12-year-old minivan, right? Who does 1,000 clicks to make one purchase. That person's probably willing to pay very little for each product, right? Relative to the one-click shopper who posts pictures of his brand new electric vehicle and has a brand new computer that costs him $2,000-$3,000, right? So firms are taking note of that information, right? I would be if I was selling stuff on the internet. If I was Google, right? I would be telling these companies who want to sell to you that this guy is a one-click shopper. He drives in a very expensive vehicle and he has a brand new laptop, right? Firms want to know that information. That's why Google gives you so much stuff for free, right? So in this problem over here, I'm going to copy this value. I'm going to make this red because this point is going to change along this curve, right? So this person is willing to pay $3.12 for this product, right? Makes sense? Now, what price does this customer get to pay? Well, the market price is $4.84, right? So this person gets to pay $4.84. Does that person feel like they won? Does that person feel like they won in that transaction, do you think?
I don't think so.
Well, I mean, if you're willing to pay 13.12, right? And you only have to pay 484, don't you walk away going, man, I got a good deal on that.
Yeah.
Wouldn't you think that? If you bought a burrito for 484, but you would have been willing to pay $13 for it, I think you'd probably walk away thinking you got the good end of that deal, right? Wouldn't you? I would. Man, I can't believe that guy. He sold it to me for 484. I would have paid 13.12 for it, right? So the difference between the market price and the price you're willing to pay is called consumer surplus, right? Well, why is it so large? Oh, times. Should be difference. B5 minus B2, right? This is your consumer surplus here. It's how great you feel about this transaction, right? This person has a surplus of 828. I would have paid 13.12, but I only had to pay 484. I win, right? That's a win for that person, right? Now, what about that second person? Well, to get that second person, all I got to do is change the 1 to a 2. And watch this point when I press enter here. Does this point move? It moved, didn't it? See that?
Yeah.
It got lower and it went to the right. What's this person willing to pay? This person's second in line, right? This person's second in line. This is Coach Kerr, right? His time isn't as valuable as LeBron, right? He's not making quite as much money as LeBron. So he's not willing to pay as much money as LeBron is. You see that?
Yeah.
The thing is, both only have to pay 484, right? Both only have to pay 484. So even though this person's willing to pay less than LeBron, right? This person still wins big, right? You see that?
Mhm.
Their consumer surplus is the difference between the price they're willing to pay, the maximum price they're willing to pay, and the 484. So 824, right? Then we got to do the third person, right? The third person here. The third person is willing to pay at most 1305. The point is further down the line, isn't it? Those persons willing to pay 1305. They're third in line, right? The thing is, they only have to pay 484, right? Everybody pays 484. This person's consumer surplus is lower than Steve Kerr or LeBron James, right? See how it works? Now I'm gonna do something here. I got to pull those down. I want to put the intercept in. So bear with me for a second. That blue dot represents the intercept, right? That blue dot right there, and that there's a red dot right next to it, right? Now, what happens is I go to the person with the fourth highest willingness to pay. We're moving down that demand curve, right? You see that? What about the person with the fifth highest willingness to pay? Right? The sixth, the seventh, the eighth, the ninth, the 10th. This person here is the 10th person in line. They're willing to pay 1280. And they win because 1280 is what they'd be willing to pay. But they only have to pay 484, right? You see that?
Mhm.
Okay. Now, how many people are buying the product at 484? How many people are buying at 484? This is when the price was high, right? When the price was high, only rich, high earning professionals like doctors, lawyers, investment bankers we're buying these French fries, right? So there's only 237, right? If I type in 237, what do you think happens? We're down here at this point here, right? So there's a bunch of high earning professionals, doctors, lawyers, investment bankers that populate the demand curve from this blue dot to this red dot, right? So you can think of these other dots as other people. This is the person with the highest willingness to pay. And of the professionals, the doctors, lawyers, and investment bankers, this person is the most frugal. This one's willing to pay the least amount. Or this person may be the newest doctor or newest lawyer or newest investment banker whose salary is not quite as high as somebody that's been doing it for 20 years, right? So either this person is frugal, right here, the red dot here is frugal, more frugal than all of his or her fellow doctors, lawyers, and investment bankers, or this person is right out of college and just that person got their first job and their salaries aren't quite as much as these experienced doctors, lawyers, and investment bankers, right? So this is what we call a marginal consumer. This person is willing to pay 480. Well, this person is willing to pay 483. There's going to be some round off error here, right? There's going to be some round off error here. But you can see their consumer surplus to one decimal place is 0, right? Because these two things are so close to each other, right? This is the market price, and this is what they're willing to pay. So down here, the maximum price the marginal consumer is willing to pay, what makes the person the marginal consumer is the fact that that market price is the most they'd be willing to pay, and that market price is 484. And that's the most they'd be willing to pay. And so the consumer surplus of the marginal consumer is 0. You know you're at the marginal consumer when the maximum they're willing to pay is the price that is currently in the market. This person is willing to pay 484, and oh, by the way, that's the price they pay, right? 44. I've been in that situation. Like when I went and saw a gastrointestinal doctor back in 2000, I don't know, 13 or 2012, when I lived in North Carolina the first time, I ended up paying a copay of like $80. And I walked away from that appointment saying to my wife, that $80 that I paid in the copay, that's probably the most I would have been willing to pay to talk to that person. And then I wondered out loud with her if what the office was going to charge the insurance company on my behalf. And I said, I bet they charge the health insurance company $500 for that visit. And sure, if they billed that hospital visit out to my insurance company at $500. Right. And now I'm teaching health economics and I'm going through this history or this theory on copays and copayments, where my intuition back then is actually how it's modeled theoretically in health economics, right? Now, the consumer surplus, we can take the maximum they're willing to pay, subtract that from the market price, and do that for consumer 1 to consumer 237. An easier way to do it is just to recognize that when we do that, we're basically calculating the area under the demand curve. And then imagine there's a line from red to here. So if you imagine there's a line from here to here, all we have to really do is calculate the area of this triangle, right? And the way you calculate the area of the triangle is you have to calculate the area. You have to calculate it by multiplying the height times the base, and then you got to divide that by 2. So what is this? This right here is the height at the blue dot. This right here is the height at the market price. So this difference is the height from the blue dot to the market price, right? From the arrow that I'm pointing with up to that blue dot. That's the height of the triangle. And this right here is the width of the triangle. From the blue arrow, right, mouse pointer to this red dot. That's the width of the triangle. If I were to do just this, I'd calculate area of a rectangle. A triangle is half the area of a rectangle, right? So I have to divide by 2. But all I have to do is copy this to here. And I can press enter. Reduce the number of decimal places to 2. And this right here is total consumer surplus. Right? Total consumer surplus is 985. That's the total benefit that accrues to the consumers who voluntarily engage in the commerce that's going on in this market. And who are the consumers at the higher price? The consumers at the higher price are what? High earning professionals, doctors, lawyers, investment bankers. So this is the consumer surplus of high earning professionals only, right? Now here we're going to assume willingness to pay and income are perfectly correlated. So the further you go up the curve, the higher your income, right? Which is a reasonable assumption given that this person has the highest willingness to pay. And of the people that are currently purchasing these French fries, this person has the lowest willingness to pay, right? And that willingness is probably in part due to income, right? And the marginal consumer, because from this dot here to that dot there, we're talking about only high earning professionals. This marginal consumer is the high earning professional that is either the most frugal or has the lowest income. Either way, the marginal consumer is a high earning professional. And we can click that to verify that we got it right. Now, suppose the price of Osgood French fries is lower to $2.42 because Osgood French Fry Company wants to expand its market into middle income American consumers, right? So what happens here is for that first consumer is still willing to pay $13.12, right? But the market price is $2.42, right? The market price is now $2.42. Osgood's only charging $2.42. So $2.42 is the price that every consumer pays now, right? Because they've lowered their price to $2.42. So what we have to do here is we have to pull this red box down to the $2.42. Now this guy who's willing to pay $13.12 for the French fries, this person only has to pay $2.42. This guy feels even better about the transaction because his consumer surplus is $10.70. What about the second person in line? The second person in line is still willing to pay $13.08, right? Mm-hmm. Still willing to pay $13.08, but instead of paying $4.84, this person is paying $2.42. So this guy's consumer surplus increases as well, right? What about the third guy? The third guy in line is willing to pay $13.05. Still willing to pay $13.05, right? But instead of paying $4.84, this person is only paying $2.42. So this guy feels really great about this transaction as well. What about the 237th high earning professional, doctor, lawyer, or investment banker. Now, this person, right, is willing to pay $483, but because the price has been lowered to $242, they're willing to pay $483, but they only have to pay $242. So they feel really good about this transaction as well, right? Now, what about the 306th person? The 306th person is willing to pay $241, right? Which is basically $242. So the consumer surplus is really close to zero, right? And how many middle income people entered the market? 69. Are there any poor people in this market? No, by assumption, right? These are high earning professionals buying these gourmet French fries. These are middle income people buying these gourmet French fries at $242 a bag, right? You see that? So the difference between this blue dot in terms of quantity and this red dot in terms of quantity, that difference is the 69. This right here is 237 people. This right here is 237 plus those 69, right? And remember, the marginal consumer, the new marginal consumer, all marginal consumers have a consumer surplus of zero. Why? Because the maximum they're willing to spend on this product is what firms are charging, and the firm is charging $242. Now, the total consumer surplus is computed by summing up the above individual consumer surpluses, right? From the first guy to the second guy to the third guy, all the way out to the last person who's willing to pay $242, the 306th consumer, right? We can add up all those consumer surpluses, or we can calculate the area of the triangle. And notice what happened to the area of the triangle. The height of the triangle is now the intercept minus this new market price of $242, right? So we got to change this. We're going to change that right there, the 484. We're going to change that to 2.42. And notice we also have to change the width of the triangle, right? We have to change the width of the triangle to the 306. Because now there's 306 people in this market each hour buying these gourmet French fries at the new lower price of $242, right? So now we're calculating the area of this triangle from this blue dot down here to the price the firm is charging $242 out to this red dot. This red dot corresponds to our new marginal consumer. So the new consumer surplus it's bigger, right? Why is it bigger? Because we've lowered the price and we've drawn more people into the market to buy our gourmet French fries. Okay, so the first 237 consumers are high income earners. The last 69 in my model, the last 69 are middle income. So the total consumer surplus measures the total benefit that accrues to high earning professionals and middle income earners, right? And at 242, the new marginal consumer is a middle income earner, right? Because the lower price drew in middle income earners into this market to buy these gourmet French fries, right? Okay, the last thing we have to do is we have to calculate the elasticity. So what I'm going to do is I'm going to delete this here. I'm going to change this to 1. Why did I change that to 1 there? Because I have 1 bag per hour. I have 237 bags per hour. And I have 306 bags per hour, right? So these are my prices. So if I charge a price of $3.12, only the wealthiest of people can afford that or are willing to pay that. I only end up selling to one. Now it says here, use this equation to calculate the elasticity. This Greek letter E, epsilon, is used traditionally for price elasticity of demand. Elasticity, Greek letter, right? I want to take 1 over the slope of demand, right? 1 over the slope of demand. I want to multiply that by the price quantity ratio at each one of these points. So if I go back here, my slope is a negative 0.0351, right? I'm going to grab that from here. See, I'm going to grab that from right here. I'm going to highlight that negative 0.0351, which is the slope of my demand curve. I'm going to highlight that. I'm going to copy it with Control C. Then I'm going to come over to here and I'm going to type equal parenthesis 1 divided by, and I'm going to do Control V to paste the number in, right? So this is the first part of my elasticity equation, right? You see that? And I get a negative 28.49. Now your number is going to be different because your slope is different than mine, right? So that's the first part of my elasticity equation. What this is, the 1 divided by this number, this thing in parentheses here is the change in quantity over the change in price. Remember, for a demand curve that has P on the left and Q on the right, this value is the change in P over the change in Q, right? So if I invert this, what I mean by invert is divide it into 1 divided by that value. Then I invert, right, the change in P over the change in Q. To invert the change in P over the change in Q, I got to say the change in Q over the change in P. Now, this only works when demand is linear. In our case, we assume demand is linear, right? So this is perfectly valid. Now I got to multiply it by the price quantity ratio, and that's pretty easy to do in Excel. Because all I got to do is I got to just put a times right here, right? I got to go over and find the price, or I can click on it. I'm going to click on the price, then I'm going to divide by the quantity. And I'm going to get an elasticity of a negative 0.58. And it says 1 decimal place, right? 1 decimal place. So I'm going to shrink the decimal place down to 1. At 237, my elasticity is a negative 0.6. Now I can just drag this down to get the other elasticities, right? I'm going to copy this. I'm going to put it right here. Okay, when my quantity is 306, my elasticity is close to 0. When my quantity is 1, my elasticity is this monstrous thing, right? Negative 373.7. Now, because the elasticity is the percent change in quantity over the percent change in price, the way I interpret these values is this. If prices go up 1%, if prices go up 1%, and I'm at this dot, if I'm at this dot and prices go up 1%, then I see a 373.7% decrease in quantity. Another way to think about that is if I'm at this blue dot where my pointer, my mouse is at, if I'm at that blue dot, my prices go down by 1%. I can get a massive increase in the quantity that is demanded, that is sold. 374%, right? When I go to 237 here, when I'm at this blue dot, if I drop my price by 1%, if I drop my price by 1%, my quantity only goes up by 0.6%. That's what the elasticity is saying. Then if I go down here, if my price is even lower, and I'm at this red dot, if I increase my prices by 1%, then my quantity, if I drop my prices by 1%, my quantity will only go up by 0.2%, right? So when the elasticities are between 0 and -1, we have inelastic demand. When the elasticity is more negative than a -1, we have elastic demand. When our price is the lowest and we increase prices a little bit, we get almost no change in what people are purchasing. That's why it's called inelastic. But if we're at a high price and we drop our price a little bit, we get a massive increase in what people want to purchase. So that's why it's called elastic, right? The last thing we have to do is we have to calculate the revenue. And revenue is just price times quantity. So here all we got to do is take the price times the quantity. And our revenue at a low quantity is low. French fry revenue increases from 13.12 up to 740.52. It rises and then falls. The maximum money that the firm can extract from this market occurs when the price is set in a way that produces a -1 elasticity. So that's something you probably read in the book. And we're gonna come back to it when we're talking about intangible goods. I'm gonna give you a table of prices and quantities that are generated along a linear demand curve, and then behind the linear demand curve is going to be this parabolic revenue curve. And you're going to see that at the top of the revenue curve, that corresponds to the point on the demand curve that has an elasticity of demand equal to -1.